If you're here to talk about software supply chains. There's been a lot of interest around this topic for a couple of years now. We're going to put a public sector spin on software supply chains. Hopefully we don't overpromise and underdeliver. First, by way of introduction, my name is Dan Moch. I work for Lockheed Martin. I've been there for a long time.
I'm William Crum. I'm a senior defense engineer at SpectroCloud and a sergeant in the Marine Corps.
Okay, so just a brief outline of what we'll be discussing today. We're going to talk about software supply chains, as I said. So we'll start by introducing that topic. Then we'll focus on explaining an architecture we put together with the Cloud Native Computing Foundation's public sector user group to help manage and automate software supply chain security. And then finally, we'll discuss ways that you all, as presumably folks who are at least interested in, if not members of the public sector, can get involved in the work that we're doing. Okay, so just to start with, we'll have a couple of definitions. You'll hear us use the word suppliers and consumers. To be clear, for any given person or entity, they may swap back and forth between those roles depending on what they're doing. Supplier would be anybody actually creating, in this case, software, and consumers would be anyone using software. And as I said, of course, in a chain, supply chain, you will have a lot of folks playing both of those roles depending on the context. Effective software supply chain security requires cooperation between suppliers and consumers. So the work that we've done is geared towards providing consumers with details on what is being provided when a supplier hands off a piece of software. That work is encapsulated mostly in software bill of materials, or SBOMs, and hopefully you caught my colleague Ian Dunbar-Hall's talk earlier this week on that topic. And then it's also important to know that consumers are getting what the supplier intended. That's where you'll hear about things like SALSA, things like in toto, making sure that software was not modified sort of in transit, so to speak. So why is S3C important? Well, there have been some fairly public incidents in the past few years that sort of demonstrate the importance, but just as a sort of general history, there are things that you can sort of mitigate with some of the things I just discussed, things like dependency confusion and typo squatting. These are when malicious actors will upload a package to, say, PyPI or NPM with a name that is very similar to an existing well-known package. And they will inject malicious software into anyone's supply chain who happens to accidentally fat finger a dependency name and download the wrong thing. Build pipeline attacks, these would involve things like messing with build agents and so forth. So there's a lot of vectors for attack in the software supply chain. And in order for us to mitigate these vectors, we all kind of have to work together collectively, or that we believe is the best way to approach this. I've also listed here compromised maintainers. This is probably, we'll get to the XZutils attack in a moment, but that would be a great example of that. Okay, so I mentioned that there were some specific examples of supply chain attacks in recent years. So let's go back to 2020. We could talk about the SolarWinds supply chain attack. There was no CVE issued against that, but that was presumed to be a nation-state attack involving compromised build systems. So in order to mitigate that, you want to have trusted build pipelines that are issuing build attestations in the style of SALSA, using isolated build environments a la something like Hermeto, and signed provenances are also a good way to mitigate those from various angles. Log4 shell, or the Log4j. This was a pretty well-known vulnerability because, as I recall, it hit around the end of the year when folks are usually celebrating the holidays, and a lot of folks got called in to mitigate this. Now, Log4j is a pretty common Java library. It's used in a lot of projects, and so folks had to sort of munch through their code bases and try to figure out where they were using a vulnerable version in order to update their dependencies. So this is where SBOMs are a great mitigator, right? They list out everything that's in your software releases, and you can throw those SBOMs into something like dependency track to get some level of proactive alerting when a CVE is issued against any libraries that you're using. And then I mentioned the xzutils backdoor. This was a compromised maintainer. There's a lot of social engineering involved here. There's a lot of good write-ups on that particular incident since it happened last year. I'd encourage you to go look those up. Here, this is a little bit trickier because there's a lot of social engineering involved, but a build provenance can help. Artifact verification can help. Maintainer identity assurance, which is probably more of sort of the boundaries of what we've been doing today, or I should say beyond the horizon, I guess, of what we've done today. I'd like to see more happen there. And then another well-known one was this changed files attack, TJ actions. Now here, I think probably the best thing to do is make sure that your build pipelines are statically defined, right? If you're using a Git tag in your GitHub Actions, those can be problematic because, of course, tags are rewritable. So best to use commit hash pinning in the case of GitHub. And mitigations would apply variously depending on what CI system you're using. So those are just some examples of attacks, probably a bit more detail than we really needed, just to sort of get a flavor for the kinds of things that we're trying to mitigate and hopefully prevent. Now, the problems that we've sort of highlighted so far are not unique to the public sector. I would argue that some of the risks are heightened in the public sector, but now we'll take just a minute to discuss some of the things that the public sector does sort of uniquely have to face. Right? These are things like air gaps. I talked about those earlier this week. We have a lot of compliance regimes in the public sector that we're beholden to, particularly in the U.S. We've got NIST 853. If you're handling credit card transaction data, you've got PCI you need to deal with. And there are a lot of similar requirements, security, let's say hardening regimes that you need to be aware of. Cost sensitivity is another issue, right? Whatever we do collectively to address the problems that we face in the public sector, they need to be very minimal in terms of cost, right? We can't afford to spend $500,000 a year to license software in most of our organizations, and so as you'll see, the architecture we put together uses, I think, entirely free and open source software. Anything else I want to say there? No, I think that covers that. I should say, and I did sort of allude to this earlier, a lot of what Will is going to share in terms of the architecture, that is coming in a forthcoming white paper that the Cloud Native Computing Foundation's public sector user group has put together. We've gone through a couple of rounds of review, and there may be another one yet forthcoming before we finally publish the paper. In that paper, we of course want to highlight the urgency of securing public sector supply chains. We just sort of spent a few moments doing that here as well. We talk about a functional and a technical architecture for how to build trust in your supply chains. In that white paper, we're not going to talk about this here, but we do talk to software registries and sort of advocate for making things like SBOMs and vulnerability exchange information available through those registries as soon as possible, just to make the sort of discovery and correlation easier between released artifacts and those software supply chain security documents. We do talk about the challenges. We've already sort of summarized those very briefly. And then an adoption roadmap for how to apply this architecture within your organizations. That is, as you'll see, there's a lot of moving pieces in the architecture, and we sort of anticipate questions along where do we get started with this. So that will all be in the white paper. What Will is going to do now is he's going to talk about and summarize that architecture. So Will.
So we're going to switch to specifically talking about the Cloud Native Computing Foundation's white paper and make specific recommendations to implementation of secure software supply chain in a scenario where a public sector organization is involved. A lot of this is specifically around OpenSSF's specific software factory pattern, in which individuals can provide software in a secure pattern, but not necessarily making specific recommendations to software applications or cloud native capabilities. So this first step specifically kind of covers everything that the supplier to shared infrastructure and then additionally the consumer is utilizing. The first step will always be a producer produces software. What does that look like? What identity does that producer have in the ecosystem? And then where does that producer share that to a shared infrastructure? The middle component is essentially the recommendation in which where multiple producers provide and share software, they should probably be doing that in a shared capacity. And then the last step is recognition that consumers still often build software. Although you are providing possibly a capability and or you're a vendor, your consumer is usually building workflows around that. So what does the build process and the policy enforcement process for the consumer actually looks like? Both the producer and the consumer is a very similar capacity, but in general, oftentimes it's not the other way around. A public sector organization usually does not provide software to the open source community. Usually the producers provide software, then give it to the public sector organization. Kind of going to the shared artifacts step is kind of more of like the middle step. So in general, the recommendation for the producer is to send their artifacts in an OCI compliant registry, and then additionally being able to send attestations in a shared capability like Archivista. In general, we want to advocate for public sector organizations to have these controlled and shared environments. This just leads to less redundant, storage of infrastructure, artifacts, and other locations. Because usually a producer sends and shares artifacts to multiple organizations, not necessarily just one. The technologies you're going to see here, the first one is any essentially OCI registry that is compliant to open container interface, and then additionally utilizing in toto attestations and then sharing that into a shared attestation store like Archivista, and then utilizing repository service TUF, so the update framework, to ensure there's additional metadata to prevent the consumer from pulling images and content that they might not necessarily need. So consumers in general, they still build software. A lot of what they're going to be doing is kind of that original step that producers are doing as well. They'll take the content from that shared infrastructure and then go and build their own projects and products. What that specifically looks like is consumers are recommended to have a runner in general, a GitLab, GitHub, and or a Tecton runner that is sharing and building salsa provenance. And then during that process, they just have continuous delivery and verification of all the content that they might need. So what that would look like for the consumer is they're utilizing something like a policy controller like OPA or a policy controller in general to grab these policies and verify their infrastructure, and then additionally utilizing stuff like SNCC and then additionally Trivy to validate the software that they're deploying. And then the last step is, although we are providing SBOMs for individuals to consume, oftentimes, the consumer will also build SBOMs because they don't necessarily trust blatantly all of the SBOMs that they are providing. So ensuring that the consumers provide all of those same things. I think we're skipping a couple slides. So kind of covering over why it specifically matters. In general, we understand that public sector organizations, healthcare organizations, and others often have mission critical capabilities. So ensuring that we provide safe and secure software without any concern of, maybe it's changing on route, changing on, artifact, ensuring that everything I'm deploying in my cross domains are consistent no matter what. In general, what this does is, this mitigates the concern of common attack vectors on if it's a typo squat, if it's a different artifact that's not supposed to be there, or if it just changes a little bit. Everything in the white paper kind of covers and leverages open source tools. The Department of Defense Chief Information Office has specifically put out doctrine recommending utilization of open source software. So that kind of is what covers in the Cloud Native Computing Foundation white paper. And then this additionally establishes a lot of different rules of engagements for cooperation across public sector organizations. If you're one organization or if you're a separate organization, having that shared infrastructure and a shared capability to send your artifacts will consistently be important. Where the open source community specifically helps, a lot of individuals don't recognize that public sector organizations and governments utilize essentially everything and then rewrap it in their own flavor. What you'll pretty much see here is a couple of examples of what the open source is doing to help public sector organizations. So the Go programming language, released in 1.24, they have specific FIPS cryptographic modules that are super great and compliant associated to NIST standards. OpenSSL for a while have been ensuring that they're FIPS compliant, and then soon to be OpenSearch also. One of the newer releases is going to be FIPS compliant. What that essentially means is, you just modifying the cryptographic library you are utilizing, you expand to be able to support public sector organizations because you're utilizing the crypto modules that they need to utilize. What you'll often see is all the software that the Linux Foundation and the Cloud Native Computing Foundation build are utilized by government organizations. They oftentimes have to rebuild, they have to rebase, and or in some cases, they can just actually pull from upstream sources if they're FIPS compliant and or NIST 853 compliant.
Okay. So we have planned for a 40-minute talk, but I think we're going to come in a fair bit under. We'll have time for questions. But before we get there, I do want to plug the public sector user group that I've already mentioned a couple times. If you are in the public sector, and we are both members of the defense and aerospace industry, I want to be clear, I'm not talking just about defense and aerospace. I am really talking about the public sector at large. If you are a member of one of those organizations, you're welcome to join that group and work with us to kind of push supply chain security forward for all of us. You see a couple links there. We do have a GitHub repository above that. There's a link to our community page under the Cloud Native Computing Foundation. We meet on Thursdays, late morning, early afternoon, depending on your US time zone. And yeah, you're welcome to join us. Any questions? I'll start by mentioning, of course, you can download the charts. The architecture slides were probably a bit busy for this sort of presentation format. You'll be able to get a closer look at them there. And then, of course, in that forthcoming white paper.
One thing I additionally wanted to add is the advocate part. Oftentimes, certain government civilians and or service members are not simply aware of technologies that we provide here at the Linux Foundation and the Cloud Native Computing Foundation. As an example, multiple missions overseas, there's things that we rebuilt that we didn't necessarily have to if we knew of these things. The Cloud Native Computing Foundation landscape and the Linux Foundation landscape is something that we need to continually advocate for on behalf of not only ourselves, but also everyone in the United States and in the world. Super useful technologies, and we just need to make sure everyone's aware of it.
Yes, question. I think there was a microphone that's going to come out for anybody asking questions. Go ahead.
So you mentioned cost sensitivity, obviously being a challenge for you, and it is for all open source projects as well. How do you, in your supply chain, do you manage identifying the open source projects that can achieve the levels of being able to support what you need versus the ones who really can't, on the cost sensitivity side, be able to spend the time to do the things that you're hoping they can do?
Yeah, so you're asking about cost sensitivity from a maintainership perspective and the time it would take to be compliant with some of the things that we're advocating for. Yeah, I think that's a really good question. And I think that the onus is on us collectively to figure out how to enable the kinds of things that we're talking about as I don't want to say low effort as possible, but as cheaply as possible, I guess, right? So GitHub does have actions that you can use to generate SLSA attestations for your releases. If you're on GitHub, that's probably a pretty easy win. I think there are foundations that will potentially fund software registries. I'm speculating, of course, but there are foundations that will potentially fund software registries to add support for some of these documents to be published alongside artifacts. And I think we need to make all that like zero cost for maintainers, right? And then beyond that, I think it's a question of how can we generate fairly decent, say, SBOM, right, without maintainers having to spend gobs of time to clean it up and make sure that everything's correct. For which, again, I'll plug Ian's talk from earlier this week. And speaking of Ian, he's going to take the microphone now.
Yeah, and I just want to jump in, Henry. I think you bring up a really good point, and I think maybe just to double down on what Dan said, like the expectation on maintainers should be to also push back and ask for help. So like I'll give you an example where we've recently been talking about should there be like a FIPS compliant version of Kubernetes, right? And like how do we approach that with the Kubernetes community? And a big part of that is like, okay, them pushing back and saying, well, how do we make sure we don't induce additional cost for verification on the ZNCF in the Kubernetes project? So the specific ask there is from those maintainers, like, okay, can we set up industry-run verification steps that turn on that FIPS compliance flag that we'll put up there for Go to begin to verify that Kubernetes still works with all the baseline testing, right? But that's run on company infrastructure to verify that it works, and then we just report those issues and contribute back when it doesn't work, versus putting onus on the Kubernetes project to support yet another version of Kubernetes as another flavor. So I think the big part of this is more than anything else is, as a maintainer, you should absolutely push back and expect people to step in and help, and helping guide folks specifically in public sector who are not maybe used to working in those open source communities on specific things they can do to support you as a maintainer better. That specific instruction helps, I think, a lot guide public sector in general who doesn't know always the best ways to engage with like open source communities.
Any other questions? Going once, going twice? All right. Thanks everybody for coming out. If you have any other questions, we'll be around.